Hello everyone, this is Godot, and in this tutorial I try to explain how you can make this realistic flashlight in Godot version 4. If you have a question, you can ask me in the comments section. And so yeah, as always, enjoy the tutorial. Okay, so we have Godot version 4 open here, and the first thing I'm going to do is to go ahead and create a new project, and I'm going to call this realistic flashlight. And I'm going to create the folder for it, and I'm going to change the renderer to forward because we are going to be using certain effects that is going to require you to have this renderer enabled. And I'm going to press create and edit. Now once your project's been created, you want to go to the scene tab and create a root node. For this project I'm going to create a 3D scene and press F2 on my keyboard to rename this to world. Now with this node selected, you want to click this add icon here, and there's going to be a new window here, and in the search panel here you want to search for static and select static body 3D. Press create, and when you add that, it's going to give you a warning, and that's because this node has no shape. So what you want to do is to select it and again click this add icon here and search for collision and select collision shape 3D. With the collision shape 3D selected, you want to go ahead to the inspector tab on the right, and you want to click this shape here and select a new box shape 3D. Now you want to click on this box shape 3D again, and you want to increase the size on the X and Z axis. Now this is going to be our ground, but right now we can't really see it in the game. So in order to be able to see it in the game, you also want to add a mesh. And for that, you want to select static body 3D again, click this add icon, and this time search for mesh instance 3D. On the right, you want to select new box mesh, click on it, and change the size on the x-axis to 20 and on the z-axis to 20 as well. Okay, so on the left, I'm going to rename this to ground, and I'm going to click this arrow icon here to collapse it. And so this is basically going to act as our ground. Okay, so now that we've added our ground, what we want to do is to create the player. And for that, there's a already made node for us that we can use, and it's called character body 3D. And you want to select the world and click add and search character body 3D, and I'm going to press F2 on my keyboard to rename this to player. And the same thing with the player applies here. You want to also add a collision, so for that I'm going to add a collision shape 3D, and for this one you want the shape to be a capsule. Okay, also I would like to add a mesh so we can see the player better in our editor. So now you can see our player is stuck on the ground. So you want to click the player and bring it a little bit higher. Now the next thing you want to do is to select the player, click add, and this time you just want to add a simple node 3D. This is going to be a placeholder for the camera. So I'm just going to call this head. And with the head selected, you want to add another node. This time it's going to be a camera 3D. Now select the head and bring it a little bit higher. Now I think it's a good time to save our scene, and for that I'm gonna press Ctrl and S, and I'm gonna save it in my res folder. Okay, so now we're done with our scene. Let's go ahead and create a new script. And for that you want to select the player, the node you want to attach the script to, and click this attach script icon. Now here you want to turn off template. And in the path, what I'd like to do is to click this browse icon here and create a separate folder for the scripts and press create. Now what I would like to do here is to click this window icon here And that's gonna make this window full screen. And I think that's a little bit easier to code and to view for you guys. Now, the first thing we want to do in this script is to create some variables. I'm going to export these so we can edit them later in the editor. I'm going to call the first one var player speed and assign this to something like 8. The next variable is going to be player acceleration, and I'm going to assign this to something like 5. Also, we need to add the jump force and the gravity. Now, if you don't want your player to be able to jump, you can ignore these steps. Now, we need another variable, but we're not going to export this one. And it's going to be a direction. And I'm going to assign it to vector3.0 for now. So now, in the process method, what you want to do is to assign the direction to the input of the player. And to get the input of the player, you just want to type input dot get axis, and now you need to pass 2 arguments here. The first one is going to be negative action, and the second one is the positive action. So for the negative action, you want to type left. For the positive one, you want to type right. And finally, you want to multiply this by vector3.right. And at the moment, we can only move left and right. So in order to move forward and backwards, you want to add this to input.getAxis backward and forward. And this time you want to multiply this by vector3.forward. Now, if you're new to Godot and you can't really understand this code, I've made a simple tutorial on how to make a FPS controller. And there I actually explain what each of these do. So if you're new, you might want to watch that first and then come back. Okay, so finally, on the next line, what you want to do is to type velocity equals to velocity dot lerp. So we want to linearly interpolate between the current value of velocity and direction multiplied by player speed, and the speed of that is going to be defined by player acceleration multiplied by delta. And you want to make sure you multiply this by delta so you keep this code consistent across all of the devices, regardless of the hardware. Okay, so now finally you want to call the move and slide method. And this is going to actually use velocity, which is a member in this character body class, and use this to move the player around, so you don't have to do anything else. Okay, so I'm gonna press Ctrl S to save this, and back in Godot, before playing the game, you wanna come to your project settings, and in the input map, you wanna create those actions that we just defined. Because remember, left, right, backward, and forward are just some strings, and Godot doesn't have an idea of what these are. So to do that, in the new action, you want to type left and create this add icon. And for left, I'm going to type A, press OK. Same thing with right. You want to click add, click D, OK, and forward, W, OK, and finally backward, I'm going to type S and click OK. Now I'm going to close this and press this play button here, and I'm going to select the current scene. And now right now, if you try to move around, you can see I can move forward, backwards, right, and left. And you can see our movement is smooth because we're using the lerp method. Okay, so at the moment we can't jump, so let's go and create the action for the jump as well. I'm just gonna call this jump, add, I'm gonna press space, click OK. Now back in your script, what you want to do is to type if input is action just pressed, we call it jump, and there's a built-in method in the character body 3D class. It's called is on floor, and it's basically going to check if we're touching the floor, and if we are touching the floor we want to be able to jump, and to do that you want to type velocity dot y plus equals jump force, and you want to come down here, type else velocity dot y minus equals gravity multiplied by delta. Now we're almost done, but you want to come up here in the velocity. Now after we multiply the direction by player speed, we also want to add velocity dot y multiplied by vector 3 dot up. And the reason we do this is because we're overriding the gravity here. So in order to compensate for that, we need to add the velocity to it. So again, I've talked about this in my FPS tutorial, so feel free to check that out. Also, if you have any questions about this code, feel free to ask me in the comments. Okay, so I'm gonna save this, and if you played it, you can see I can jump and there is gravity. So now we can move around and jump, but we can't look around. So let's learn how to do that. Now, back in the script, what you want to do is to reference the head and the camera. And the easiest way to do that is to type at onReady var head, and you want to type a $sign and type the name of the node, which is head. And for the camera, you want to do the same thing. Call this camera head / camera 3D. And we use the / because camera is the child of the head. Now in the input method, what you want to do is to check if we are getting any mouse input. And to do that, you want to type if event is input event mouse motion. Now, first you want to create two other variables, and these are going to be head y rotation. Just going to call this head y axis, and camera's x axis. So what you want to do is to type head y axis plus equals to event dot relative dot x. And for the camera, you want to type camera x axis plus equals to event dot relative dot y. Now to be able to control this, we also need a mouse sensitivity and acceleration. So I'm gonna create these up here. Export var camera sensitivity, assign it to something like 0.25, and we also need var camera acceleration and assign this to something like 2. And you also want to multiply both of these by camera sensitivity. Now the typical way you would do this is to rotate the camera and head on the same method. But instead, we're going to rotate the camera and head in the process. And that's because we're going to be linearly interpolating them. And so in order to have access to delta, we want to do it in the process. So what I'm going to do is to type head dot rotation dot y equals to lerp. And we want to interpolate between the current rotation of the head and head y-axis, and the speed of that is going to be defined by camera acceleration multiplied by delta. If you save just this and played it, you can see I can look around on the y-axis, but it's really fast. And the reason it's really fast is because we actually need to convert this to radians. And to do that, you want to type dec to rad and then put head y-axis in that. So if we play this again, you can see the speed is actually more reasonable, but it's kind of reversed. And the way you fix that is just by adding a minus. Okay, so I'm going to do the same thing for the camera. Rotation dot x lerp, copy this, put it here, minus, and this time camera x-axis. Okay, so I'm gonna save this and play it, and you can see we can look around, but whenever we move our cursor outside the window, we exit the game. And let's try to hide that. Now we want to hide the cursor when we play the game, and the easiest way to do that is to come to the ready method here, and this is going to be called once the node itself and the children are ready, and you want to type input dot set mouse mode and input dot mouse mode captured. Also, you want to be able to exit the game, so in the input method you want to type if input dot is key pressed. I'm going to use the escape key, and whenever we push the escape key, we want to be able to exit the game. And to exit the game, you want to type get tree dot quit. Okay, so if you save this and play the game, you can see my mouse is captured, and now if I try to press escape, I exit the game. Okay, so now we have a functional FPS controller. Let's add the flashlight. And you want to select the player, add a node 3D. Again, this is going to be a placeholder for the flashlight, and I'm gonna call it hand. And with the hand selected, you want to click the add icon again and search for spotlight and select the spotlight 3D. Now when you add the spotlight, you want to go to the inspector tab, and on this spot I'm just going to increase the range a little bit, and I'm going to decrease the angle to something like 15 degrees. That should be fine. Now in order to see the flashlight, I'm also going to add a vol, and for that I'm just going to duplicate this ground by holding Control D, and I'm going to rename this to vol and rotate this on the x-axis 90 degrees and bring it a little bit forward. Okay, now let's try to make this scene a little bit darker, and the way you would do that is by getting rid of your sun in the scene. But right now we don't have a sun in the scene. So the reason we have this lighting here is because we have this option enabled here. So if you click that, you can see there is no sun right now. But there's still some ambient lighting, and in order to get rid of that, you want to click these three dots here and click the add environment scene, and it's basically going to add this world environment to your scene, and it's just basically going to give you a bunch of options. So if you go to background and drag this energy multiplier until it's 0, and now you can see it's completely dark. And right now if I played that, you can see there is my flashlight, but I can't move around and I have no control over it. And the reason for that is because we have control over head and not the hand. So we want to be able to separately control the hand. Now you could drag this hand under the camera, and if you play this, you can actually see we can move the camera around. You could do that, but it's a really cheap effect. And one better way to do that is to actually control this separately. And to do that, you want to go back to your script and you want to reference the hand and the flashlight, just like you did with head and camera. So I'm going to call this hand, and the next one is going to be the flashlight. So hand, spotlight 3D. And so you want to scroll down in the process, and the same thing with the head and camera, but this time we don't want to add the interpolation because we want to be able to move the flashlight first, which is the effect we're looking for. So hand dot rotation dot y equals to head y-axis, and you also want to convert these to radians. And for the flashlight itself, you want to rotate it on the x-axis. So camera x-axis. So if you save this and play it, you can see the flashlight is not really following your mouse, and that's because you need to also add minus on both of them. And now if you played it, and now you can see the flashlight is actually moving first and then the camera. Okay, so I've added these cubes to the scene so we can see the scene a little bit better. And you could say we're done with the game right now. Now, the first problem with this code is that if I, for example, looked at my right and pressed forward, you can see I'm not moving towards right. And the reason for that is because back on our script, we're multiplying this left and right by vector3.right and backward and forward multiplied by vector3.forward. And these are fixed values. So we're always going to move towards a certain direction and not where we're looking. Now, in order to move towards where we're looking, you want to multiply this by head.basis.x and backward and forward by head.basis.z. Now, if you ran the game, I'm gonna look at my right, and if I pressed forward, I'm actually moving backwards. So what we want to do here is to swap these values here. So forward for the negative action and backward for the positive action. And now I actually move towards where I'm looking, like an actual FPS game. And the other problem we have with this code is that we have no limitation on the camera's x-axis rotation. So I'm actually going to increase the background light a little bit, set this to like 0.5 so we can see the scene a little bit better. And if I played this, you can see if I keep scrolling up, I can endlessly rotate on the x-axis, which is not really ideal. So the way you would fix this is by getting back to your code, and on the input method, just below these two lines, you want to limit only the camera's x-axis. So you want to type camera x-axis equals to a method called clamp camera x-axis, and you want to clamp this value between negative 90 degrees and positive 90 degrees. And now if we actually played the game, and I'm going to keep looking up, and I can't go higher anymore. And same thing with looking down, I can't go down anymore. So now we have the camera's x-axis limited to negative 90 degrees and positive 90 degrees. I'm going to change this background back to 0. And the next thing we're going to add is the volumetric lighting. But the first thing you need to do is to enable that. You want to go to your world environment node, and on the inspector, you want to go to the volumetric and you want to enable this. And now if you played this, You can see at the moment there's no volumetric lighting. And that is because you need to go to your flashlight under the player, and on the light, you kind of want to increase this a little bit. I'm going to set it all the way to 16. So now if I play this, you can see I have this volumetric lighting effect. And to further increase this, you can go back to your world environment, and on density, you can increase this further. So for example, 0.16 should be fine. And now as you can see, we have a very strong fog effect on the flashlight. Now the next thing I'm going to do is to move the flashlight slightly to the right to give it an illusion of holding it in your hands. And to do that, what I'm going to do is to select the camera and click preview. And I'm going to turn off this sun, so we're seeing the actual view from the game. And I'm going to select the flashlight, and under the transform, I'm going to move it a little bit to the right. Something like that. And a little bit further. Now, you don't want to touch the y-axis on the flashlight itself. If you, for some reason, need to change the y-axis on the flashlight, you want to do it on the hand. So for example, you change the y-axis on the hand itself, and only change the x and z-axis on the flashlight itself. So now I'm going to press play, and you can see it kind of looks like I'm actually holding the flashlight in my hand. Now there's something else you could do to make this look a little bit more realistic, and that is to add a cookie texture. And so for example, I have this cookie texture here, and it's a PNG, and I'm going to drag it into my res folder. And then after you import the image, what you want to do is to drag it into the projector. And when you add a projector, what you also want to do is to enable the shadows, otherwise it won't work. So if you play this now, you can see we have the cookie texture projected on the wall. Now I'm going to increase the range to like 15 and the angle to 20. And also, if you want to intensify the effect of the flashlight, you could decrease this camera acceleration value here to something like 1. And now if you plate this, you can see the camera is moving way slower than the flashlight itself, which might be the effect you're looking for. Also, what I'm going to do is to change the color to something a little bit more bluish. That's the final result. You could play with these values later yourself to fit the game that you're making. So that's it with the tutorial. I hope you enjoyed it, and please consider subscribing to the channel if you're interested in my tutorials. And as always, thanks for watching.